Okay, guys, so we're going to do the actual math for this chapter, the linear motion problems. We're going to take apart a word problem. I'm going to show you ways that you can solve for speed and velocity with the exact same problem. So let's go ahead and read it. Sunny went east 30 meters, so I need to draw this out if I were working this problem. I've already done that for you, but just draw it out with arrows. Then he turned north and went 40 meters. So notice here I've done my vectors, east, north, and for now we're going to say east is positive, north is also positive. Okay. So what was the distance he traveled? We remember that distance is not concerned with direction, right? This is a scalar quantity, a scalar quantity. So with this, all I need to do is add up my distances, all right? So I have 30 meters, and I add 40 meters, and I get 70 meters is my total distance traveled. Okay. Don't worry about that squiggly M. Okay, so that's easy, right? Now displacement is where it gets a little tough, because when we were doing just one directional motion, like we had 30 meters this way, and let's say we had 40 meters this way, it'd be really easy, right? We just subtract them because they're going opposite. I'd end up with 10 meters west, right? And then with 10 meters west, if this was east, and that was west, east and west. But right now, we don't have this, right? We don't have this situation. We have, where we're turning at a 90-degree angle. So what we have to do is we kind of have to think about this as a triangle. So I went to the right and up, so my resultant vector is the hypotenuse of a triangle, okay? It's the hypotenuse of a triangle, which is why I've given you the equation up here, the Pythagorean theorem, where the hypotenuse is equal, the square of the hypotenuse is equal to side A squared plus side B squared, okay? So what do I have? Do I have a hypotenuse? No, I don't. That's C, right? I have A and I have B, the legs of the triangle. So this is what I'm going to do. I have 30 squared plus 40 squared is equal to C squared. And what you can do is we're going to go ahead and solve for C squared. How do you get rid of a square? You have to square root it, okay? Square root. Whatever you do to one side, you have to do to the other. All right, and if you put this in your calculator, you find out that the square root of 30 squared plus 40 squared is actually just 50, okay? 50 meters is your C, okay? The displacement here is the square root using the Pythagorean theorem, all right? Okay, now, go ahead and use the guess method on this problem. If it took her 10 seconds, remember we underline all of our vecs. Here's my t. What was her speed? Right, speed is s. Right? So let's look at our equations. What was a given that I had? I have this is a given right here. I also have 50 meters displacement is a given as well. 70 meters is distance. So be very careful, look at your equation, and then go ahead and try the guess method. Go ahead and pause it, try the guess method, and see if you can solve it. Okay, so this is what you should end up with. So we have 10 seconds is my time. I have, since we're doing speed, we look at our equation for speed. This is distance and time, right? So I can't use displacement. I cannot use displacement. I have to use distance. Okay, so my distance is 70 meters. Good. My unknown is speed. Okay, so my equation is, remember we have to solve for the correct variable. Distance divided by time. Okay, if you didn't get up to this step, pause it and try it out. All right, see if you can do it. Do it without looking. Okay, I'm going to substitute. What was my value for distance? 70 meters divided by, what's my time? 10 seconds. Don't worry about that, school. That's 10 seconds right there. So gross. Okay. I'm just going to rewrite it. 70 meters divided by 10 seconds. Okay, so don't worry about that. Same thing. All right, so what are we going to end up when we solve? 70 divided by 10 is what? 7 meters per second is our speed. Okay? All right, now try the exact same thing, but this time we're solving for velocity. Be very careful with your givens. Pause it and try it out. See if you get the right answer. All right, so our givens this time, we still have the same time, 10 seconds. Okay, 10 seconds is still our time, but this time, when we look at the velocity equation, solving for velocity, this is displacement divided by time. So can I use 70 meters here? No, because that's distance, right? My displacement I got from solving the triangle I'm solving the hypotenuse of the triangle. I have to use 50 meters this time for my displacement. It's kind of confusing, but be very, very careful. Remember, displacement is a vector quantity, distance is a scalar. Okay, my unknown this time is still kind of like the speed with direction, right? Velocity. Cool. Or if you weren't able to get up to here, see if you can make the equation. See if you can do the substitute. Pause it and try it out. Okay. So now we have velocity is equal to displacement over time, right? This is pretty easy, displacement over time. Okay, now let's go ahead and substitute. Substitute means to plug in, right? Okay, my displacement is 50 meters, make sure to use units, divided by 10 seconds. Okay, good. Keep the units, right? They don't cancel out. 50 divided by 10, I put it in the calculator, and we get 5 meters per second. Okay, so look at the comparison between the speed and the velocity. Why do we get different numbers? Why is speed much higher, but velocity lower? Well, remember that when I was walking back and forth in the classroom, if going down the row of the classroom is 10 feet, my distance goes up even if I turn around. So I go down the classroom, here's 10 feet, 20 feet, 30 feet, 40 feet. But if I'm talking about displacement, how far I actually moved from my starting point, it would be 10 feet, 0, 10 feet again, 0, 10 feet again, 0. That's a lot of fun. So you see that the displacement is a vector quantity. It depends on which direction you're going. So velocity, which uses displacement, is also going to be a vector quantity.